I'm analyzing the out-of-bag (OOB) score, a crucial metric in BaggingClassifier. The OOB score estimates the model's performance on unseen data, using data points not used in each individual tree's training. It's like testing your model on a separate test set that was never part of the training process. A low OOB score indicates something isn't quite right. The problem is that I'm getting a really low OOB score, around 0.5, which is basically random guessing for a binary classification problem. I'm using BaggingClassifier, which is an ensemble method that combines multiple decision trees. A low score tells me there's a fundamental issue, either with my decision trees or my data. I think there are two main explanations for this low OOB score. Decision trees are susceptible to overfitting, meaning they learn the training data too well, performing brilliantly on the training set but poorly on new, unseen data. This is a likely culprit for my low OOB score. I think my trees are memorizing the training data instead of learning the underlying patterns. My data might be noisy, containing errors or irrelevant information, or lack sufficient information to make accurate predictions. Even the best model can't magically extract accurate insights from bad data. Let's look at possible solutions, but keep in mind they might not solve the problem completely, especially if the issue is fundamentally with the data itself. Increasing the number of decision trees in my BaggingClassifier might marginally improve performance by averaging out some of the noise introduced by individual trees. However, if the problem is overfitting or poor data quality, it won't fix the underlying issue. Think of it like taking more opinions on a topic. It helps somewhat, but if the individual opinions are bad, the average won't be great. I'm analyzing how well a BaggingClassifier, a type of ensemble method in machine learning, performs. Bagging, short for bootstrap aggregating, combines multiple models to improve prediction accuracy and robustness. We're using scikit-learn's BaggingClassifier for a binary classification task, predicting one of two outcomes. The model uses decision trees as its base estimators. The out-of-bag (OOB) error is consistently low, around 0.5, which is basically random guessing. I need to figure out why this is happening. I'm given a scenario where a BaggingClassifier, using decision trees as the building blocks, is performing poorly. The OOB score, which estimates the model's performance on unseen data, is very low, near random chance. The question asks which explanations make sense. Option A suggests that the individual decision trees are likely overfitting. That's a very plausible reason. Overfitting means the model learns the training data too well, including its noise and quirks, resulting in poor performance on new data. Option B suggests that simply increasing the number of decision trees in the ensemble will magically fix the issue. I'm not so sure about this. While more trees can sometimes help, it won't address the underlying problem of a bad base model or noisy data. Option C suggests the problem lies with the data itself. The data could be too noisy or lack informative features. This makes the model's prediction a difficult task, regardless of the model type, and that's definitely possible. Option D suggests that switching to a different model, like an SVM, will guarantee improvement. That's a false assumption. While an SVM might perform better in some cases, it is not a guaranteed solution if the problem is inherent to the data. This is just stating that I am answering multiple choice questions. I see a low out-of-bag (OOB) score, around 0.5. This means my model is performing no better than random guessing on data it hasn't seen before. This is a big red flag indicating a serious problem with the model's ability to generalize. It's not learning the underlying patterns well enough. The low OOB score tells me the model isn't generalizing well. This means it's learning the training data too well, possibly overfitting, or that the data itself is the culprit. I need to investigate both possibilities. Decision trees are known for their tendency to overfit. If the tree is too complex, it might memorize the training data instead of learning generalizable rules. A low OOB score with a decision tree makes overfitting a strong suspect. I should consider simpler trees or tree pruning techniques. Even the best model can struggle with bad data. If the data is noisy, contains errors or irrelevant information, or doesn't have enough relevant features, it will be hard to build an accurate model. This is another equally likely problem. I'm assessing your understanding of ensemble methods and model evaluation. We are investigating why a bagging classifier model consistently produces a low out-of-bag score, indicating a poor ability to generalize to unseen data. We'll analyze potential causes and evaluate the proposed solutions. This is the overall context. We're using Scikit-learn's bagging classifier, a powerful ensemble method, for a binary classification task. The focus is on interpreting the model's performance, specifically the OOB score, which is very important to judge a model. The core issue is that the OOB, out-of-bag, score, a measure of how well the model generalizes to unseen data, consistently scores around 0.5. For binary classification, 0.5 is essentially random guessing, not good. It points toward potential issues with either the underlying model or the dataset itself. This is highly probable. Decision trees are notorious for overfitting. A low OOB score reinforces this suspicion. Overfitting means the tree is learning the training data too well, and consequently performs poorly on new, unseen data. Another plausible explanation: even the best model can struggle if the data is inherently noisy, lots of irrelevant information or errors, or doesn't contain enough relevant information to reliably make predictions. Garbage in, garbage out. While increasing the number of estimators, decision trees in this case, in bagging classifier can sometimes improve performance, it won't magically fix fundamental flaws in the base model or noisy data. Switching to a different base estimator like an SVM, support vector machine, might help, but it's not a guaranteed solution. The root problem could be data-related, regardless of the base estimator. We see a consistently low out-of-bag, OOB, score, around 0.5. This is a big red flag. For a binary classification problem, 0.5 means the model performs no better than random guessing. This tells us something is wrong with our model or data. OOB score is a measure of how well bagging classifier generalizes. I believe the decision tree, which is the base estimator in our bagging classifier, is overfitting the training data. It's learning the training data too well. That means it's capturing noise and specific details in the training set, making it perform poorly on unseen data. That's why the OOB score is low. There's a chance the dataset itself is problematic. It could be too noisy, too much random error in the data, or maybe there just isn't enough useful information to learn a good classifier. Increasing the number of estimators in bagging classifier might help a little, but it won't fix the core issue. Think of it like this. If your base estimator is already flawed, adding more of them won't magically make it better. The improvement would be very small. Switching to a different base estimator, like an SVM, might help, but it is not guaranteed. The problem might lie in the quality of data itself. A better base estimator may slightly improve the performance, but if the data is inherently noisy or uninformative, any classifier will struggle. This section title tells us we're going to analyze how well a bagging classifier model performs. Bagging is short for bootstrap aggregating, a technique that combines multiple models to improve accuracy and robustness. We'll be focusing on understanding why the model might not be working as well as expected. The core problem is that a bagging classifier model, using a decision tree as its base, shows a consistently low out-of-bag, OOB, score. About 0.5 for a binary classification task, which is basically random guessing. We need to figure out why this is happening. This statement suggests that the decision tree, the individual model within the bagging classifier, is learning the training data too well. It's memorizing the training examples instead of learning the underlying patterns, resulting in poor performance on new, unseen data. This is a common problem with decision trees. I think this is a likely culprit. This suggests that using more decision trees in the ensemble might fix the problem. While adding more trees can help, it won't magically solve the underlying issue of overfitting or noisy data. I think this is unlikely to solve the main problem, though it might offer a slight improvement. This proposes that the data itself is the problem. If the data is too noisy, contains errors or irrelevant information, or if it doesn't have enough relevant features, even the best model will struggle to produce accurate predictions. I think this is another strong possibility. This says that switching to a different type of model, like an SVM, is guaranteed to improve performance. While an SVM might be better suited in some cases, it's not a sure thing. The problem could still stem from poor data quality. I wouldn't bet on this one. This is likely a placeholder for a diagram that would visually represent the bagging classifier and its components. It doesn't directly contribute to the analysis of the specific problem.